Okay, let's do one experiment on virtual image, right? It's actually a virtual image experiment, right? And for this case, let's use a Premiere. That's one of these way, right? How we can calculate, right, the position of the image. Well, imagine that we have an object, right? And the object reflects light or could emit light like a lamp, right? So we have light coming from the object, is reflected by the plane mirror, right? And an observer is right observing the image of this object. And the image is found to be behind the mirror, right? Because it's behind of the mirror. We cannot see that image on a screen. If we cannot see it on a screen, the image is called virtual image, correct? Okay. The purpose for today's experiment is to find the distance from the mirror to the virtual image, right? And it's found from the theory, from the experiment, that we call this distance from the object to the mirror dO, and the distance from the mirror to the image di. Today, let's try to prove that dO is equals to di. Correct? This is for the case when we have a plane mirror, right? Let's try to see one more time that dO is equals to di, right? And let's do it in a second. Okay, in today's experiment, we need a piece of paper, right? We have this line that is the reference for the mirror. The plane mirror is gonna be right here. Let's locate the object at that point, right? At some distance from the mirror, right? Okay, now we have the mirror right here, a plane mirror, correct? Let's place this mirror on this line, the reference line, right? Perfect. And as you can see, we have the image right there, right behind the mirror. Now let's try to hit that image with a laser, right? With a laser to create lines that connect, right? The image. Okay, so we have for this experiment a laser, right? This is a laser that you can buy in a store, right? It's a pencil, a laser pen, right? Okay, now let's create the laser, right? Like in this case, right? Now let's try to hit the image, right? Which is right there. You can see, right? I'm hitting that image, right, very close, like this. Okay. Now let's trace the path of the laser on the paper, right? So to do that, we use this reference line, right? Now let's project the line right on the paper, right here on the bottom, right? And also right here where we have the impact, correct? Close to the mirror, right? Imagine it's very close to that one. Imagine. Do very carefully. So it says one ray. Let's change the angle, right? Imagine now we have this angle right here. One more time. Let's locate the image. Okay, perfect. We're hitting the object right in this way with the laser, correct? And one more time. Let's trace the path of the laser on the paper, correct? This is one point right here. Let's go to the mirror, close to the mirror. Okay, imagine it goes right there. Perfect. We can take another one, correct? Imagine that we're moving to this position. Okay, one more time. This is the connection to the image, right? And one more time, let's create the path on the piece of paper, correct? Okay, like this one. Okay, it's 1 point. Okay, let's go to the mirror one more time. And it's gonna be right, the position right there. Perfect. Now let's connect out of this point right behind the mirror. Okay, let's do it. So it's done. Now let's do it. Let me connect all of this point, correct, to see where they meet behind the mirror. Yes, we have this line. The first line is this one. Okay, so it's one. Let's go for the second one. Correct. The second one goes in this way. Let me see that the next one looks like a second one. Something happens right there. Okay, and we have one more like this. Correct. Now the points where this I'm going to be more accurate, try to have the other one because they're supposed to meet right at the same point. Imagine this is the situation right here. Correct. Now the point where they meet is the point for the position of the image, the virtual image, and that's gonna be the point right there. Now if we measure the distance from here to here, right, it's about 10 centimeters, correct? Right here we have 10 centimeters. What should be the distance from here to here? The distance from here to here, right? Actually, it's the reference line, right? The first one, it's gonna be 9.3 centimeters, right? The distance from here to here is about 9.3 centimeters, right? 9.3 centimeters, 9.3 centimeters, right? Okay, this experiment must be done very carefully, right, to create a better approx, right? They're supposed to be the same. As you can see, they are close, right? But this is one of the techniques that we can use to find the virtual, the distance of a virtual image. Okay, let's continue for today's experiment. Now you can do this at home by yourself. Imagine that you have, again, this plane mirror. You have the object right here. We know already the distance from the mirror to the object, 10.7 centimeters. Now let's try to find the distance from the mirror to the image, right? Again, the same technique, but now you have to do at home. Okay, so let's try to, again, hit the object, right, by the laser using the image behind, correct? We have to adjust the mirror right here, like in this case, right? So we can see actually that we are hitting right the laser is through the object, means also to the mirror, the image over there, right? Now let's trace the path again, followed by the laser on the piece of paper. Okay, let's do it. So let me do it more carefully right here. Okay, this is about this position. Okay, this is one. Let's go to the mirror right here, right? This is exactly there. Imagine. Okay, hopefully this is the best one. Okay, right there. Okay, let's go for another position, correct? Imagine we are right there. Perfect. Let's try it again to hit the object one more time. The object, well, we need to use different height right here. Okay, better this one. Okay, see, we are right there, right here in the passing through the object right here and right there to the image. Perfect. Now let's go to trace the path on the paper with the laser, right? Okay, let's do it. More or less it's gonna be, let me do a different position right here, right? More or less is where, right there. Okay, I did it. Now let's go to the other point, right by the mirror right there. Imagine. Okay, there. Perfect. We can make another one you want to. Okay, one more because you are so happy today. Okay, let's try this one one more time. Let's try to hit the object and the image, correct? Okay, it looks like we need more paper. Okay, behind. Okay, better this one, I think. Yeah, a little bit better. Okay, let's make this angle right here, correct? More paper right here. Okay, much better. Look, kind of. Okay, there. Okay, I did it. Perfect. One more time. Let's try to trace the path right on the paper, correct? Perfect. Around here. Okay, now by the mirror right here, right? Great, great. I can't believe it. Okay, right there. Okay, now for you at home, please you get this point, and let me give you the position for each point, and you can recreate this experiment at home. Okay, look from this line, which is perpendicular to the mirror right here, we have the first distance right here is gonna be 3.6 about. Look, this distance is about, okay, let me do it this way, right? This distance from here to the first point is about 3.6 centimeters, correct? That goes with this distance right here, right, which is about 6.6. Maybe you can see from in the video, right, from here to here is about 6.6 centimeters, correct? Okay, so we have this line, correct? You can do at home. It goes in this way, right? Now you connect, extend this line to the other side, correct? Now let's go to the next one. The distance from here, right, to here is about 4 point, let's see, you can see a 2, right, what am I, this one, okay, like a 4.7, okay, so the distance from here to here is 4.7, we said, right, it's gonna be 4.7 centimeters, correct? And the distance for the next one, right, in this way, imagine, okay, let me do it first right here, is gonna be what? Now about 9.4, okay, so the distance from here to here, correct, is 9.4, okay, perfect, this is 9.4 centimeters, correct? Again, let's trace at home, you can do it, okay, a line from these 2 points, we have the dimensions, just rewrite the dimensions, right, in a piece of paper like this one. Okay, and the last point right here is gonna be the distance from this reference line is gonna be 6.6 more or less. Okay, so the distance then for this point is 6.6 centimeters again, and the distance for the last point right here is gonna be, let me do it this way, okay, it's gonna be you can see it too, about 12.8, okay, 12.8 centimeters. Again, using that information, please mark the points and trace lines, right, that join this point, and also project this line to the other side, and you will see right here the point where all these rays meet. Imagine it's right here, right? Imagine you have to do it. If that's the situation, right, you need to find, right, the distance from this point, right, to the point that you get all the rays meeting or converging, correct? Imagine this is what, 9.5, okay? This is for this sample right here, right? Di is equals to 9.5. Of course, it's gonna be different. It's just I'm guessing, right? Because I want you to do it. Okay. After that, please find the percent error. Correct. Percent error is equals to, right? DO minus DI, right? Divided by the average. DO plus DI, right? Divided by 2, right? Times 100%. Because right here we don't have a standard value, right? A true value. So when that happens, sometimes we use, right, this average to get the best approx, right? Please do at home, and that's gonna be the experiment for this case, which is virtual image, right? We are looking again for the virtual image. It's right here, virtual image, correct? We can calculate, we cannot see it because it's virtual, but we can calculate it right in this way. Okay, hopefully you will enjoy this experiment and you can do at home. Okay, and that is this beautiful experiment. Okay, see you in the next experiment. Thank you.